Hi, and welcome to this video on long division of polynomials. This is the second video in the series of 4 videos or so. In the first one, I'm going to do an example. If you haven't watched it already, if you're coming in cold turkey, you might want to go back and look at the first video where I kind of talk about the process and the important things about long division and synthetic division. All right, so here's the first problem. First of all, notice 3 different ways that we can write division problems. I can just say, hey, divide this by this. I could write it with the division sign and say, here's the first one, divide it by this. I could write it as a fraction, divide. They all mean the same thing, okay? So be aware of that and just be able to read and understand what they're asking you to do in each problem. For long division, here's what I do. Whenever I divide something, just like I did in the last video. Remember, we write it with the thing in the inside of the division sign that we wanted to put on top. That's the numerator. The denominator goes on the outside. And the biggest thing here is that every power of x must be represented. So as I go along, look at this. I'm going to divide it by top. I have cubes, squares, first power, constant. So I'm good there. Here, I have first power, constant. So I'm good there. Okay? And what I'm going to do then is I'm just going to write it like this. I'm going to say, okay, inside goes the numerator. That's x cubed plus 5x squared minus 7x plus 2. It's okay to spread it out a little bit and write big. You'll like the space. You'll appreciate that. On the outside of my long division sign, I put the x minus 2. Now here's what I do is I'm only going to go through. Don't worry about the negative 2 right now. And don't worry about these things. I'm just going to concentrate right now on just the x and the x cubed. And all I want to know is, does x go into x cubed? And it does. X cubed is much bigger. What would I have to multiply x by in order to get up to x cubed? Well, I'd need 2 more powers of x, right? Which we say not as 2x, but x squared. X times x squared would give me x cubed. So that's the value that goes on top. Now, just like I do with numbers, what I do at this point in time then is I take this x squared and I multiply it by the thing out here. And I'm going to write the result of that down underneath. So I'm going to take x, and this is a distributive property problem. X squared times x is x cubed, and then x squared times negative 2 is negative 2x squared. Now, here's the tricky part. I'm not adding these values together. Remember in the last video how I talked about how I don't take 12 and the 10 and I add them, I take them and I subtract them, right? So we need to take then this next line, and we need to subtract this line here from the line directly above it. So I'm going to draw a line here, and I need to subtract the entire thing. Now here's the key. I'm not subtracting x cubed, and I'm not subtracting the 2x squared. I'm subtracting the whole piece of information. Subtracting is the same thing as just flipping the signs and adding, right? And so really what I'm doing here is I'm taking x cubed minus x cubed. If I do it right, that should be a 0 every single time. But now I'm going to take 5x squared, and pay attention here, ready? Subtract a negative 2x squared. If you prefer, you can just take the signs and flip them. Subtracting a negative is really adding, in other words. So I could go through if I wanted to and just say, you know what? That's a negative. This is a positive. Get rid of that so I don't have to deal with it. And that's the same thing. Some of you guys will like that. So flip the signs, and now I'm adding 5 plus 2 gives me 7x squared. That's the same thing as 5 minus a negative 2, right? Now, just like you do in long division, whenever I get done with this, I always drop the next value down, right? And I write it right next to it. So what we're going to do then is we're going to say, here I have 7x squared, and we're going to drop the negative 7x. 7x squared minus 7x. And now I'm going to repeat the process. Up here, I'm looking at just the x. Does x go into 7x squared? It does. It goes into it. Now see, I need a 7, and I also need an additional power of x. So I'm going to write plus 7x right here. The reason I do that is because 7x, now I'm going to go through and multiply out, same as I did last time. 7x times x minus 2, distributive property problem. 7x times x gives me 7x squared. 7x times a negative 2 gives me negative 14x. I draw a line. I'm going to subtract the whole thing, okay? I'm going to subtract everything here. I can either think of it as 7x squared minus 7x squared, or I can go through and I can flip the signs and I eliminate this guy here so I don't have to worry about it. And now I add, which I think is easier. 7x squared minus 7x squared, nothing. Negative 7x plus 14x's, which is the same thing as subtracting a negative 14x. That gives me 7x's remaining. Now I come through, I drop the positive 2 here, I repeat the process. Does x go into 7x? It does, 7 times. I don't need any additional power of x's, so I say plus 7. And now I come and I distribute out. 7 times x, 7x. 7 times negative 2 is negative 14. Draw a line, flip the signs, add. Add those two together, they equal 0. 2 plus 14 gives me 16. I have nothing left to drop here, and I look up here and I say, well, wait a second here. This is x. That doesn't even have an x. I can't take something that has more x's and put it into something that doesn't have any x's at all, right? So that means that down here has become my remainder. So, how do we write that? Well, just remember, like when we did with numbers, we get to a problem with the remainder here, and we say, well, we used to do in like 4th grade, we said 24 remainder 1. As we learned about fractions, we'd say 24 and an additional 1/5. 24 and an additional 1/5. Why the 1? Because that's the number here. Why the 5? Because that's what we were dividing by. So, how we write it here is we say that we have x squared plus 7x plus 7, right? And an additional 16 from here. And instead of dividing by 5 in this problem, we're dividing by x minus 2. 16x minus 2ths. And that is our answer for this particular problem. It's a long process, right? It's long division. So it's complicated. The big ideas here that we just hit, okay? Concentrate on just the x. What does it take to get him to go to this? Put the number at the top, distribute out, flip the signs and add. And you repeat until you get down to the point where x no longer goes into it because there are no more x's, right? X will go into 7x just fine, but x does not go into something that's smaller. So you look for the power here, and you compare it to the power of x here, and you say, all right, well, is that one smaller than this one or equal to it? That way I can keep on going. All right, so there's the first problem. Turns out synthetic division, we could have done this in like 4 seconds, but you don't know synthetic division yet. We're going to get to a problem where you do need long division in just a second with this problem. All right, hopefully that makes sense. A couple more examples and we'll practice in class so you'll get a chance to nail this stuff down.